Yeah, rule 3. When you're going to say that given a curve differential equation in that rule 3, when your q of x, when q of x, it's in the form of x to the power of k, where k is your arbitrary constant. What you have to do here for finding the pi, first write your pi formula, where pi formula is equals to 1 by f
1
of
by f
d
of d into q
into
of
q
x.
of x, which is equals to 1 divided by f of d into x to
X
the
to the
power
power
of
of
k.
k.
After that, what you're going to do to this f of d, you're going to reduce this f of d in such a way that you can use your binomial expansion by taking out the lowest degree term. So this f of d will get reduced to 1 plus or
1 minus
minus
d.
phi of d,
D.
not 0, phi of d. You're going to reduce this 1 by f of d in such a way that it should be in the form of 1 plus or minus phi of d by taking the lowest degree
Okay.
term from that one. So it will get reduced to 1 divided by 1 plus or minus phi of d into x to the power of k. After that, what you're going to do, you're going to take this term to the numerator. When this denominator term is going to the numerator, what is going to happen?
Inverse.
Yes, 1 plus or minus phi of d whole to the power of minus 1 into x to the power of k. After that, you're going to apply here binomial expansion. You're going to open it this one. Expand by using binomial expansion.
Expansion.
I will give you some of the expansions. Then after that, what you have to do, you have to operate. You have to operate this x to the power of k to each and every term of that bracket. You have to multiply this x to the power of k to the each and every term of this bracket terms. Some of that the expansion forms which we are going to use frequently for this type of a problems for under your rule 3. They are the first one, frequently using.
Okay, ma'am.
Make a note of this one. Frequently using expansions. First one, when it is in the form of 1 by 1 minus d, that you can write
D. 1
1 minus
plus
d whole to the power of minus 1, which is equals to 1 plus
1
d
plus
plus
d plus
d
2d
square plus
plus
d cube
d
plus
cube
so on.
so
Next
on.
one, it's going to be 1.
1 plus d.
Yes, good, very good. The second one, it's going to be 1 divided by 1 plus d, which is equals to 1 plus
1 plus
d whole
d
to the power of
inverse.
minus 1. It's equals to. Now here it's going to be alternative. 1 minus d,
Minus
then
d
plus d
plus
square
d square
minus
minus d
d
cube.
cube plus so on. Next to the third one, it's 1 divided by 1 minus
1
d
minus d square.
square. It's equals to 1 minus
1
d
minus d
whole to the power of
minus
minus 2.
2.
It's equals to 1 plus
1 plus
d
2d plus
plus
3d
3d square
square
plus
plus
4d
4d cube.
cube plus so on. Next, when it is a plus, it's going to be alternative again. Then your fourth one, 1 divided by 1 minus d, sorry, 1 plus whole square. It's equals to 1 plus d whole minus 2. It's equals to 1
1
minus
minus
d
2d
plus
plus
3d
3d
square
square
minus 4d
4d
cube
cube.
plus so on. Next, for cube, it's what? And
1 plus 3d
mm,
plus 6d
mm,
square
mm,
plus 10d cube.
very good. 1 plus 3d plus 6d square plus 10d cube
Cube.
plus so on. Next it's going to be alternative 1 by 1 minus d to the plus whole cube, which is equals to 1 plus d to
One.
the power of
D.
minus 3
Minus
is
three.
equals to 1 minus 3d
Three.
plus 6d square minus 10d
Minus.
cube plus so on. So these expansions are important. Frequently we are going to use only. Most important is the first these two. Maximum you're going to have a problem based on these two methods
Hmm.
only. Maximum. They are the important. Now you will take a problem. You'll see one problem where a problem solve
Solve.
d square plus d plus 1 of y, it's equals to x cube. First, already the given one is in operator form, so no need to write in the operator form. Directly we'll go for finding the auxiliary equation, that is m square plus m plus 1, it's equals to 0. Now this is in the quadratic form. We cannot solve by using that finding that common factors. So which formula you are going to use? Minus b plus or minus under root of b square minus
Minus 4 is
4ac divided by 2a.
A.
So what is your a value here? Here a is equals to 1, b is equals to 1, c is equals to 1. You're going to take the coefficient. This is in the form of your ax square plus bx plus c.
Hmm.
Next, its m is equals to minus 1 plus or minus under root of 1 whole square, it's 1 minus 4 into 1 into 1 divided by 2 into 1, it's
1.
equals to minus 1 plus or minus under root of 1 minus 4, it's equals to minus
Minus
3
3
divided by 2,
by
where
2.
your I square value is equals to minus 1, then your I square it's equals to minus 1, I is equals to under root of minus 1. So this minus we can write as an I we can write. So your m it's equals to minus 1 plus or minus I root 3 divided
3
by 2,
by 2.
which we can write 1 by 2 plus or minus I root
I root
3
3 by
by
2.
2. Now it is in the form of a complex roots. This value,
Al-
where this value it's equals to for alpha, this
alpha.
stands for alpha, and this value stands for beta. The
Beta.
roots are complex roots.
Hmm.
The roots are complex roots. Therefore, complementary function y suffix c is equals to e to the power of alpha x of c1 cos beta x plus c2 sin beta x. Y suffix c is equals to complementary function. Y suffix c is equals to e to the power of, where alpha value is equals to 1 by 2 into x, c1 cos beta value is equals to root 3 by 2 into x plus c2 sin root
Sine
3
root
by
3 by 2.
2 into x. This is got over. Our complementary function, it's completed. Half of the problem is got over. Now we have to find that pi. To find next second half, to find pi,
I.
where pi is equals to 1 by f of d into q of x, where your f of d is equals to d square plus d plus 1, q of x
1.
is equals to x to the power of k.
X 3.
Yes. Now this denominator we have to write it into the form of 1 plus or minus phi of d. So 1 already itself. This two term will make that is equals to our phi of d. which is equals to 1 divided by 1 plus of d square plus d. I am making that term it's equals to one term into x cube. Now I will take this to the numerator so that it will become as an 1 plus of d square plus d whole to the power of minus 1 x to the power of 3. So we are having that knowledge of the by using the binomial expansion, we can open it this one. The second formula 1 plus d whole to the power of minus 1. We know that which is equals to 1 minus d plus d square minus d cube plus so on. This term completely, this is going to be completely your d. This term it's completely your d term.
D.
So it's going to be as in a what? Your pi is equals to, it's 1 minus d is equals to d square plus d, then plus d
D
square
square
plus
plus
d
D
whole square
whole cube
minus of
whole square
d square plus d whole cube
whole
plus
cube.
so on
So on.
into x cube, because next I'm going
Cube.
to write for 4, 5 and etc. It's going to be 0. Now what you have to
Hmm.
do? You have to open this one first. Open it. It's
Hmm.
equals to 1 minus of d square plus d, then plus a plus b whole square formula. D to the power of
D4
4 plus
plus
2
D
d
square
square into d cube
D
plus
cube
d.
plus D square.
Yes. Next,
D,
a plus b whole cube. A plus b whole cube is what? D to the power of
D square,
square
ma'am.
and whole cube it is there. That is equals to d power 6. D power 6 plus 3 d square of n whole square. It's equals to d power 4. D power 4. What is your formula here? I will write. A plus b whole cube it's equals to a cube plus 3a square b plus 3ab square plus b cube. Now
Cube.
what you're going to get here? 3a square. A square of an whole square is equals to a power 4. A power 4 into d. It's a d power 5 then plus 3. D square into d square. It's equals to d power 4 then plus d cube plus so on into x cube.
Ma'am, second one is D square.
Which one?
Second bracket.
Second bracket. This one. How square it going to be? A
A
plus
plus
b.
B whole
Huh?
square.
A plus b. A plus b whole square, which is equals to a square plus 2ab plus b square. What is our a
Hmm.
here? It's a d square. D square into d, it's a d cube.
Hmm.
Here you're saying,
Hmm.
it's equals to square. Right. Which is equals to. Now what we are going to get here? Now we are going to multiply that x cube to each and every term. It's going to be x cube minus then d square. Simultaneously I am multiplying that minus also. D square x cube minus d x cube then plus d power 4 x cube plus 2d cube x cube then plus d square x cube then minus d power 6 x cube minus 3d power 5 x cube then plus 3d power 4 x cube then plus d cube x cube plus so on. Where d stands for?
Differentiation.
Yes, it stands for differentiation. Where d
चलो खा
into
खाओ
d into x cube, which is equals to
Cube.
3x square. Next,
X
d
square.
square x cube. First time differentiation, it's got over. That is around 3x square. One more time when you're going to do, it's going to be
6x.
6x. Next, d into, d cube. D cube into x cube, it's equals to 6.
6.
Then d power 4 x cube, it's equals to 0. Then remaining
0.
completely, it's going to be 0.
0.
Substitute all these values into the equation number 1. Substituting
Hmm.
above values in equation number 1. Pi, it's equals to, what is our equation number 1?
X cube.
What do you say, Minna?
Okay.
X cube,
X cube
x
minus
cube
3x square.
minus d square x cube is equals to 6x. Next term is what?
6x. 3x square.
3 dx cube, it's equals to 3
X square.
minus 3x square. The next term it's what? D power 4 x cube. D power 4 x cube, it's equals to
0.
0
0.
plus 0. Next is also it's coming 0. No. 2 into d cube and x cube, it's
No.
equals to
6.
6
12.
plus 2 into 6. Next term it's equals to what? D square x cube. D square x cube is equals to 6x
0.
plus 6x. Next term d power 6 x cube, those values is equals to 0. Then minus 0 minus 0 minus 0 only. This is going to be, this also has to be
Yes, ma'am.
minus. We are multiplying minus
Which?
no simultaneously. So here it has to be
No.
minus only. This 0 and this 0. 0 0 0. How many 0 I have written? 2 zeros. One more 0 has to come over here. Then it's equals to 0 minus d cube x cube is equals to 6. Simplify this one, you will have your answer. It's equals to x cube, then minus 6x plus 6x will get cancelled, minus 3x square. The next is 12. 12 minus
12.
6 is equals to plus 6. This is your pi. Now we have to write general solution, where general solution is going to be what? General solution is equals to complementary
P
function
F
plus
plus Pi.
particular integral. Y is equals to y suffix c plus y suffix p. Y is equals to what it was? E power minus alpha, no? Alpha value is equals to what? Minus 1 by 2.
Yes,
E
ma'am.
to the power of
E
minus 1
minus
by
1
2
by 2.
into c1 cos root 3 by 2 into x plus c2 sine root 3 by 2 into x, then plus x cube minus 3x square plus 6, which is the required solution. Yes, is it clear, Sharmin? Is it clear for you?
Yes,
What you
ma'am.
have to do with the third module? Shall we move to the fourth module, or shall I give you one homework problem? One homework you take down. The combination of all the three.
Yes, ma'am. Homework.
Solve.
मैम
Hmm.
मैम मैम
बोलिए माँ.
ये प्रॉब्लम हम लोग करे थे
Hmm.
यहाँ पे कांस्टेंट में 6 है ना मैम
Hmm.
12 आया था
तो कहीं मिस कर दिए आप.
पीआई
यस. क्लास में करे थे.
हाँ मैम
बोर्ड प्रॉब्लम या होमवर्क प्रॉब्लम?
बोर्ड प्रॉब्लम
Then madam missed somewhere. It's a 6 only, not 12. Then next problem, solve dq plus 2d square plus d of 5, it's equals to e to the power of 2x, then plus x square plus x, then plus sine 2x. Now you see how many rules are there. This solved by which rule?
Ax first rule.
Yes. And what about this? Which rule it's going to be?
Second.
See properly. X square plus x is solved by which rule? This
Oh,
goes
x to
under
the
which
power of
account?
k.
Which rule that is?
Third.
Third rule. And this is going to be solved by rule second.
2.
So what you're going to do? First find your PI1, then PI2, then PI3, then combine it. If you can do
Hmm.
simultaneously, well and good, you can. If not, you split that one, divide it into
Hmm.
that some sub parts. You take as an a PI, complete
Hmm.
PI is going to be PI1 plus
Hmm.
PI2 plus PI3. This solving by this one, and this by solving this one, and this solving by this one. Well, then when you're going to combine it, that's going to be the complete PI. Then write your general solution. It's going to be complementary function plus particular integral. Yes, take this one problem. It's enough, more than enough, because all the three methods it's got covered in that one.
Okay, ma'am.